Welcome to The Explainer. Today, we're setting the stage for a mind-bending forensic investigation into the fundamental fabric of reality itself. So for all you focused learners out there, get ready, because we are going to completely deconstruct the universe as you know it.
I want you to do something for a second. Just look at your hands. Now look at the physical space around them. It seems pretty real, right? I mean, it might be empty, but it's undeniably there. Or is it? What if it's not? Is the space between us just an illusion? Today, we're directly challenging that deeply held assumption that physical distance is a real, objective thing.
To understand why we're even questioning the existence of space, we have to define the core mystery that totally breaks classical physics: quantum entanglement. This is the phenomenon where two particles act as a single system, instantaneously correlating across vast distances, literally no matter how far apart they are. It's like flipping a coin in New York and having another coin in Tokyo instantly show the exact same result. Albert Einstein famously called this spooky action at a distance. It's the ultimate puzzle in physics, and setting up this problem gives us the foundation to explore two radically different paradigms that try to solve it.
Okay, let's dive into this. Paradigm 1, ER equals EPR and connecting the cosmos.
So in this first mainstream view, physicists have theorized that space-time itself is actually built from quantum entanglement. This is famously known as the ER equals EPR conjecture. Basically, it posits that entangled particles aren't communicating faster than light through empty space. No, instead, they are physically connected by microscopic, hidden tunnels in the space-time fabric. Einstein-Rosen bridges. You probably know them better as wormholes. In this model, the entanglement literally creates the geometry of the physical world.
Now, what's really interesting about this slide is how we visualize that underlying geometry. Take a look at this diagram from our sources. Physicists affectionately call this the Python's lunch. Notice those narrow constrictions at the ends, and then boom, this massive central bulge right in the middle. It shows us how bulk entanglement theoretically creates massive internal volume, basically out of nowhere. It's a highly dynamic, geometric explanation for how two distant points in space are physically woven together.
But hold on, what if that entire framework, the literal bridges of space and all that complex geometry, what if it's just wrong? This sets up a titanic clash between two totally different worldviews. On one side, we have the mainstream ER equals EPR model, which relies on physical wormholes. But on the other side, we have this radical, highly disruptive deterministic framework waiting in the wings. It's a model known as the finite observer theory, and it argues that space itself is nothing more than a thermodynamic illusion.
Which brings us to Paradigm 2, the finite observer theory, or FOT.
Introduced by researcher Nikolaos Kouhogenes, this theory presents what's called a verbless framework. In FOT, the universe is eerily perfectly static. It proposes that the universe is just a static n-dimensional tensor network, essentially an unmoving, multidimensional web of data points. So all those dynamic verbs we normally use in physics, like evolution or interaction or computation, they are mathematically false here. The universe doesn't actively do anything, it simply exists as a hyper-equilibrium. Furthermore, it defines human observers as having a finite Shannon capacity. That means our structural ability to perceive this massive network is strictly limited. And because everything is static, even time itself isn't flowing. It is merely a static topological gradient.
Because of those limits we just mentioned, we experience what FOT calls a dimensional partial trace. Think of this as a lossy holographic compression. It algebraically restricts the infinite, global pure state of the universe down to fit the observer's finite capacity. Imagine the universe as this infinitely massive, uncompressed dataset. Your localized observer boundary acts like a rigid bottleneck. So the crucial point here is that the infinite universe is mathematically forced to compress into a much lower resolution 4D projection just so you can actually interface with it.
And this completely reframes the whole mystery of quantum entanglement using a concept called topological aliasing. In this framework, entanglement is absolutely not a wormhole connecting two distant points in space. Actually, it's the exact same single relational coordinate in the static network. But because of our severe sampling limits, it accidentally gets projected twice onto our macroscopic screen. It's kind of like a single digital pixel, breaking and mapping to two completely different spots on your computer monitor. The particles aren't communicating, they are literally the exact same node existing in a higher dimension.
Let's move to the next slide and see how this builds.
When we map these theories out, a really stark contrast emerges. Look at the holographic quantum error correction model at the bottom. It relies on redundant boundary encoding to literally build wormholes. But contrast that with finite observer theory at the top. Its ontological substrate is entirely static relational information, and space-time emerges merely as an entropic projection based on Landauer's principle. It treats space not as a physical container, but as a byproduct of our own cognitive data limits. Crazy, right?
The implications of this are absolutely wild. Under FOT, the things we consider fundamentally real, like rest mass, gravity, and the flow of time, they aren't actual physical substances or forces, no. They are simply the entropic artifacts of that dimensional compression we talked about earlier. They're the thermodynamic data exhaust created when the infinite static network is forcefully compressed to fit inside our finite observer boundaries. Mass and gravity are literally just the invariant entropic residue of your own limited perspective.
And that leads us to the climax, an illusion of space.
So we've contrasted the complex, hidden wormhole codes of the holographic model against the stark, unmoving geometry of FOT, and it all leads us to this profound conclusion from the source material. Macroscopic spatial separation is a thermodynamic illusion rendered around the nodes. Really think about what that means. The vast distances separating objects in our universe, the space between your eyes and the screen, the massive void between galaxies, none of it is actually there. Distance itself is not a physical reality. It's merely a thermodynamic illusion. It's an artifact of our own coarse-grained rendering of a completely static, singular reality.
It fundamentally changes how we view reality. So I want to leave you with this provocative question to ponder today. If the physical space between us is just an illusion created by your own structural limits, what else in your reality are you simply projecting? Thank you so much for joining me for this explainer. Keep learning, keep questioning the very nature of your reality, and I'll catch you next time.